Welcome to our third in a series of LED videos from the General Electric Company. We are located at the Institute in Nela Park in Cleveland, Ohio, and Current, powered by GE, is happy to bring this LED tube information to you. Our first and second videos in this series were on LED basics and LED reliability. As we move forward with these videos, we hope you find these valuable and helpful. My name is David Korow, and I'll be your speaker for this video about LED tubes. The video content is shown on this slide, and this is really meant to give you an easy way to move about the video by simply choosing the begin and end times for the topics of interest. This will prevent you from having to view the entire video every time you're trying to find a single item. Underwriters Laboratories is an organization that was created to do safety testing for electrical and electronic products. They were created back in 1893, and their purpose is to create safer living and working environments. UL has created a number of different types of LED tubes, and we're going to go through those now. Those tubes fall into three different categories. Each one has pros and cons, and as we go through this presentation, hopefully you'll gain a better understanding as to which one of these LED tube types is right for you. This slide notes the three types of LED tubes that are sold in North America: UL Type A, UL Type B, and UL Type C. What I'd like to do is walk through each one of these three types, noting that the items that are in yellow are pros, and the items that are in gray are, let's say, negatives. If we weigh the pros and cons, the negative and positives for each one of these different choices, we can then choose which choice is going to work best in our application. If we start out with UL Type A, you'll notice that I have a couple items in blue. The first one shows a UL Type A tube, and that is a necessary part of this system. And a UL Type A tube will require an old fluorescent ballast. So these are referred to oftentimes as plug and play. The electronic ballasts need to be either instant start electronic or program start electronic ballasts. They will not work on the old electromagnetic types. Because Type A tubes are a quick and easy change out, you simply take out the old glass fluorescent tube and replace it with your new LED Type A tube. It is the quickest of the three as far as installation. Also, due to that quick installation, it's also the lowest cost. Now, the cost can certainly increase if the old fluorescent ballast needs to be replaced. If the old ballast that's in there is less than 5 years old, probably no need to replace it. Let's move into some of the detractors. When we go from a fluorescent dimming ballast system, which might be used in a school or an auditorium, please note that most Type A LED tubes on fluorescent electronic dimming ballasts will not dim. Now, the GE UL Type A tube, they are dimmable, but they're only dimmable on about 80% of the dimmable fluorescent ballasts out there in the market. So this 80-20 rule is going to be showing up a couple times with Type A. The second detractor for Type A is system compatibility. There are literally hundreds of different fluorescent electronic ballasts installed in the market today. We have created a list that is available to you on the internet that lists the fluorescent electronic ballasts that we know will work with our tubes. In that case, you have 100% compatibility. If, however, your tube is going on an electronic fluorescent ballast that is not on our list, what we're finding is the 80-20 rule falls in again. Applying the 80-20 rule says that 80% of the time, the GE UL Type A LED tube will work on your existing fluorescent electronic ballast. 20% of the time, they will not work on your existing electronic fluorescent ballast. Many office buildings have thousands and thousands of ballasts. Those ballasts have been changed out throughout the years. Herein lies the problem with Type A. Most likely the owner of the building or the team of people that are maintaining that building don't know exactly which ballast is in which fixture. when fluorescent lamps were used, ballasts were standardized, so different ballasts from different companies work just fine with standardized lamps. Because we don't know which ballast is in each fixture, there's no way to know if the tube that you're trying to use is going to be compatible. And that's why the LED tubes from GE need to be checked against that list. Finally, if you're concerned about the reliability of your new LED system, understand that you're putting on a very long-lived lamp. That lamp is going to be used on potentially a very old fluorescent electronic ballast. The life of the product is going to be rated on the weak link in the chain, and therefore the old ballast is going to set when that system's going to fail. So those are the pros and cons for Type A. It's about 3 and 3. Let's move on to Type B. Now, Type B is referred to as a bypass ballast, which requires the entire old fluorescent ballast to be removed. The mains, or the 120 or 277 volt line that was feeding to the ballast, now go directly to the UL Type B LED tube. Let's look at some of the pros for the Type B. The Type B tube has the driver actually inside the tube. That means if the light source fails, no longer does the maintenance crew have to determine whether it's the ballast or the lamp that failed, like was done in the past with fluorescent. With a Type B, since the driver is integral inside the tube, if the tube fails, it doesn't matter if it's the light source or the driver. The tube failed, put in another one. So that's a benefit. Don't have to worry about figuring out what's wrong. Just change the tube. I talked about compatibility issues, that 80-20 rule with UL Type A. Well, with Type B, that goes away because you've got your line voltage going directly to the LED Type B tube, either 120 volts or 277 volts. The maintenance savings are obvious. I don't have to worry about replacing ballast. I just have to keep the tubes running. Those are 3 high points for Type B. Let's move into the negatives. The Type B tube is going to require an electrician. Therefore, it's going to be the greatest cost because this electrician probably has never done a Type B retrofit before. It requires removing the old ballast and possibly removing the tombstones or the sockets, depending on if you have a double or single-ended tube. We'll talk more about that in a minute. Wires will have to be spliced. It's not as simple as simply flipping out an old bad ballast with a new fluorescent ballast. This is a total rewire. Also, because of safety concerns, GE is requiring that a fuse be installed. The wiring harness that you see on the slide here is actually 2 tombstones with the series fuse wired in directly. That is actually something that GE is selling as part of these systems to make it easier to install, in this case, single-ended LED Type B tubes. If dimming is required, remember on Type A, you've got about the 80-20 rule. In Type B, you have 0 dimmability. So with Type B, even if dimming is needed, as soon as that dimming fluorescent ballast is removed and a Type B wired lamp is directly connected to the line, dimmability is no longer available. Now, that old fluorescent ballast that was taken out, there's a lot of electronics in that ballast, and that was there for a number of reasons. But the front end on that ballast had what we call immunity built into it. So if there were line voltage transients or other dirty line anomalies going into the old fluorescent ballast, it typically could absorb those, and neither the ballast or the bulb would be damaged. But now with this little itty-bitty driver crunched inside that tube, the immunities had to be removed. So the driver is a weakness in Type B LED tubes. And because of that weakness, I've got it as a detractor. Yes, you don't have to worry about replacing it, but the problem is you're going to have tubes dying more often if you have a dirty line. Whereas in the Type A situation, you still have that fluorescent ballast there to protect the tube. UL Type B tubes come in 2 different versions. There's something called a double and a single-ended. Now for maintenance folks, this is going to be a nightmare. They may know that they have Type B tubes in their building, but they will not know which one's single or double-ended unless they've kept a very good diary of what they've installed or they've marked it on the fixtures. Single-ended means that the line and the neutral go to one end of the bulb and the other end of the bulb is simply there for mechanical attachment. Double-ended means that the neutral goes to one end of the bulb, the high side goes to the opposite end. Now this also introduces the problem of shunted and unshunted sockets. The majority of electronic fluorescent ballasts out there are instant start, and they have shunted sockets. A shunted socket will not work with a single-ended type B because a shunted socket shorts out the two leads on the one end. So if you're going with a single-ended type B, you have to use unshunted sockets, which means you may not only have to remove the ballast and the tubes, you may also have to rewire and buy new tombstones for your unshunted socket need. Now once again, the wiring harness that GE provides is for the single-ended, so they are unshunted tombstones. A concern with Type B tubes is the following. At the end of a Type B tube's life, the maintenance crew is going to come in and put in a replacement tube. Question's going to have to be asked, do I put in a single-ended or a double-ended? And then there's the possibility of a third option, putting in an old fluorescent tube. So let me explore that. Putting in an old fluorescent tube into a Type B fixture poses a safety issue. With the ballast removed, that fluorescent tube has nothing to prevent excessive current flowing through it in the event that it actually starts. Now it's unlikely it's going to start on a 120 volt Type B fixture, but on a 277 volt fixture, the likelihood is increased. With a single-ended Type B application, with a fluorescent tube being placed into that fixture, the cathode within the fluorescent tube is going to fail immediately. That hot cathode could possibly break and fall off inside the tube, touching the glass and possibly cracking or breaking the glass tube. Now on a double-ended Type B application with 277 volts across it, if the tube starts, there's nothing to limit the current in that tube except the circuit breaker back in the lighting panel. Drawing 15 or 20 amps through that fluorescent tube could cause it to catastrophically fail. These are two safety concerns that need to be addressed before installing a Type B solution. So there's your layout or your overview of Type B. Let's move on to Type C. Type C requires an electrician. It does require removing the old ballast and putting in a new driver, and it does require a brand new Type C tube. I think it'd be appropriate now to mention that Type A, Type B, and Type C tubes are not interchangeable. Once you choose an A, a B, or a C solution, you've locked yourself into it, and that's what you're going to be stuck with unless you move to a different family. So none of these are interchangeable. Only an A works on an A, meaning a fluorescent ballast. Only a B works because it's direct wired, and only a C is going to work on the right remote LED driver. Let's look at the pros on the UL Type C. If we're worrying about reliability, my problem is with Type A, you're using the old fluorescent ballast, could be a reliability issue. Reliability with Type B is going to be weak because of that little driver without any immunity built into it inside the tube. If you want reliability, you want to go with an external driver, and that's what's required for a Type C. That external driver is going to be designed exclusively to work with that LED tube. There'll be no incompatibility. Also, if you want to add controls, you can buy a Type C driver with dimming wires, the gray and purple wires. The other thing is with Type C, the driver puts out low voltage DC, somewhere in the neighborhood of 25 to 35 volts. The chance of getting electrical shock is greatly reduced with that. Let me go back to Type B. If you've got 277 volts going directly into that tube, either single or double-ended, there is definitely a chance of getting shocked. Now we know code says you must shut the electricity off when you're doing any kind of work this way. Any type of relamping, certainly any kind of Type B or Type C ballast removal and driver or Type B rewiring. Unfortunately, we all know that typically when lamps are being replaced, electricity is not turned off. And herein lies the problem with Type B. That 120 volts on those two pins or 277 volts on those two pins are not being limited by anything other than that fuse that GE requires you to use on the B type. That's going to limit your current to about 1 amp. And you still got the full voltage there. And with Type C, with the low voltage, there is greatly reduced electrical shock issue. Let me move back to Type C. Type C, no compatibility issues because you now have a dedicated remote driver with your brand new Type C LED tube. And then finally, GE's just introduced a family called Lumen Choice. Now, Lumen Choice is a really cool Type C alternative. It allows you to buy a single lamp and run it at up to 4 different lumen levels by simply adjusting your Lumen Choice driver. So Lumen Choice bulbs and Lumen Choice drivers are matched together. You buy one tube, one driver, and you now adjust your driver to whatever light output you need, and you put the same tube on every single driver. It's a really cool system. We'll go into it more at the end of the talk. What are the negatives on Type C? First one we've already mentioned, requires an electrician, but that electrician is going to be pretty good at this because he's taking out the old ballast and then she's putting in a brand new LED driver, which by the way is exactly the same size. All the wires are there. You simply remove it, you splice in the new wires, put in the new tube, and boom. Medium installation cost. So out of the 3, the question always comes up, what's the most expensive? Well, A is going to be the least expensive if you just swap out the tube. If you change out the tube and the ballast on the Type A, that's going to still be the least expensive. Type C is going to be your medium or middle of the road cost on installation. And what we're finding is Type B is the most expensive to install because it requires a total rework of all the wiring in the fixture. And then finally, the other negative with Type C is that because the drivers are not standardized, once you buy a GE Type C driver, you're really going to have to stay with GE tubes. And likewise, if you buy somebody else's, you'll have to buy their tube. There's really no crossing of manufacturers with different manufacturers' drivers. Tubes and drivers are really dedicated right now. At some point, they will become more universal, but today you really are stuck with staying with a Type C tube and a Type C driver from a single manufacturer. That's it for this slide. Hopefully you've got a good overview of what Type A, Type B, and Type C mean. We're now going to move on to a quick financial look at what the relative costs are between A, B, and C. This slide was put together to give you an idea as to what's going to be the bottom line for my installation cost if I go with a Type A and use the old ballast, a Type A with a new ballast, a Type B which requires a complete fixture rework, or a Type C which just simply means swapping out the old ballast for a new driver, and then a Type C tube. I'm assuming here a 4-lamp fixture. You see my tube costs here are just about the same across the board. Type C's $1 cheaper than a B or an A. Drivers, well, the only place where we'd have to either buy a driver or replace a ballast would be a Type A with a new ballast. I'm putting $15 in for that new ballast, which is compatible, and we've checked it because it's on the list. Or I've got to buy a Type C driver, which is mandatory if you go with a Type C solution. Job times are in minutes, so I've got 4 minutes to just simply swap out a bulb with the old ballast for Type A. For Type A with a new ballast, I got to swap the bulb and put a new ballast. I've got 10 minutes. Type B, I've got the toughest because there's a lot of rewiring, 15 minutes for that. And then Type C is just like Type A with a new ballast, 10 minutes. Also note that out of these 4 choices, 3 of them require an electrician. I chose $93.20 an hour for the electrician. And for Type A with the old ballast, just swapping out the lamp, you can get a lamp maintenance company to do that for about $15. The thought here is the cheapest, least expensive winner is Type A old ballast, $50. Type A with a new ballast, $78.53. If you go with a Type C, you're at $77.53. And if you go with a Type B, that's the highest cost, $81.30. Now I ask you to put your own numbers in. This is just really a mental exercise to get you thinking about what it costs to do this. Put your own numbers in and see what makes sense for you. Rebates and incentives are something that's driving the industry. A Design Lights Consortium maintains a list called the Qualified Products List, the QPL. And what I'd like you to do, if you're going to be doing anything with upgrades in your lighting, contact your local utility, find out if they have any rebates or incentives, find out the difference on their rebates and incentives for DLC Premium and DLC Regular, Find out if the tubes that you're thinking about buying are actually on the qualified products list. If they are, make sure you get pre-approved by your utility. What we're looking at here is typically upwards of a 20% savings off the cost of the tubes if you get this utility rebate. Don't ever ignore the possibility of a rebate or an incentive. Just make sure you find out what it's for. Are they rebating A tubes, B tubes, or C tubes? Some utilities are only doing A tubes. Some are doing all three. You need to find out what is happening with your local utility. So this is just more of a reminder. Check with your local distributor if this is all new to you. Find out what they know about your local utility. Really, the easiest thing to do is just get on the utility website and look up rebates and incentives and see what they are offering. Can save you a lot of money. Now, the tubes that I'm going to be talking about on the next slide, all the details that you need, you can get on this website, www.led.com. When you go to that website, I want you to click on the Resources tab that you see on the top in the orange. When you click on that Resources tab, a menu will drop down. You want to open up the library. Once you open up the library, there'll be a search window. In that window, I want you to type the word AWAKEN, A-W-A-K-E-N. That will take you to a PDF link. When you open up that link, it'll get you into the AWAKEN brochure. Every product I'm going to talk about in the next few minutes is in that brochure with the order code and a description. What I've done is I've taken the AWAKEN brochure information and I've condensed it down to 2 pages. The first page will be UL type A, B, and C, including type C lumen choice. And the second page will be the drivers that are available for type C, both regular as well as lumen choice. So let's look at these products. So the GE LED family breaks down into these major categories. You'll notice that I have it broken down on these 2 spreadsheets on either half of the page. Type A and Type B is on the left. I've got Type A that are both T8 and T5. I have Type A, T8s and T5s that are glass and plastic. And then I have tubes that are in various wattages, ranging over various lumen levels. You'll notice that our typical color temperature range is somewhere between 3,000 and 6,500. We have tubes that are both 2 foot long, 3 foot long, 4 foot long, and 8 feet long. We also have U tubes, the U 6-inch center to center and the U 1 5/8 center to center. Notice that our life ratings vary between 70,000 hours and 50,000 hours. And then finally, notice that I do have a group of these tubes that are labeled Reveal Tri-Gain. And the Reveal Tri-Gain tubes are going to give you your superior R9, CRI, and lumens per watt. Also note that on the Type B, those are only available in glass. And likewise, their CCT range from about 3,000 to 5,000 Kelvin. They are available in 2 foot, 3 foot, 4 foot. And also note that all the Type Bs do require that inline fuse. On the right-hand side of the screen, I've got something brand new to tell you about, and that's our GE Lumen Choice Type C family. It includes a bulb with a driver. Now, what's really cool about these drivers is you choose an individual tube, and it can run at many different lumen levels. The tubes come in T8s, they come in U tubes, they come in T5s, they come in glass, they come in plastic. Notice all the wattages, notice the color temperatures, once again, are around 3,000 to 6,500. Life, some are 70,000, some are 50,000. Let me also note that our plastic tubes are NSF. They are rated to be used around food, so please take note of that. Also, some of our tubes are made in the USA. So if you're a government or need Build America Act products, we do have those as well. So this is just a summary. It's certainly not complete. Please go to that AWAKEN brochure. The AWAKEN brochure is updated about once a month, so it is very useful. Let me take you to our next page, which is our C drivers. Type C drivers come in 2 groups. They come in regular, and you'll notice that they come in different wattages that will run either 2 lamps or 4 lamps. Also note that some of them are dimmable. Also notice the Lumen Choice drivers at the bottom. Those will run 2 lamps or 4 lamps. Those actually will not be out until first quarter 2019. They will be 120 or 277 volts. The Lumen Choice tubes are out today. The drivers will be out in the next 3 months or so. That's a high-level overview of our products that we're offering in our LED family. Let me answer a question here that often comes up in our discussions, and that is, what LED tube do I buy regarding lumens? Let me walk you through this exercise. You've got an F28T8 standard lamp in your ceiling today. You look in the GE catalog, you find out it's rated at 2675 lumens. That's a good thing to know. Question is, do you need a 2675 lumen LED to replace it? And the answer is absolutely not, and let me tell you why. The first reason is that 2675 lumen lamp in your fixture is running on some electronic ballast that has a ballast factor. It could be a low ballast factor, or normal ballast factor, or a high ballast factor. What you need to do is find out what your ballast factor is and multiply that lumen level by that number. I'm going to assume it's a normal ballast factor of 0.87. So if I take my 2675 lumens times 0.87, I find out that my needed lumens for my LED replacement is only 2325. But I'm not done yet. Now, one of the things you need to know that when you took that 2675 lumen lamp on your normal ballast factor, which dropped it down to 2325 lumens, you put it in a fixture. And that fixture did not have 100% efficiency. Some of the light was lost in the fixture. It just simply never made it out. It bounced around in the reflector. It was absorbed in the reflector. It never made it through the lens. So I'm going to put in a 90% efficient reflector, which is going to reduce that 2325 by an additional 10%. And now the lumen level that we're looking at is 2095 lumens. Is that the lumen level you want for LED? No, it's not. There's more to be talked about. There's another issue with those fluorescent lamps, and it has to do with ambient temperature effects. That lamp that's running at 2095 lumens only runs at that lumen level at exactly 77 degrees Fahrenheit. And if you're not running your air in your fixture at 77 degrees Fahrenheit, you are always going to be lower lumens. So if you go higher than 77 degrees Fahrenheit or lower than 77 degrees Fahrenheit, you are going to lose lumens. I'm going to assume that you're going to lose another 5% of your lumens on the average because of temperature variation. So now you're down to 1990 lumens. Thing is, we're still not done yet. Now, one of the things that manufacturers typically don't tell you, but GE will, is that that 0.87 ballast factor pertains only to an F32T8. You've got F28T8s, which means that that ballast is a different ballast factor for your lamp. In fact, it drops from 0.87 down to 0.81. So I have to redo my calculation. So I take my 2675 lumens times my new ballast factor of 0.81 times 0.9 for the loss in fixture efficiency times another 0.95 due to temperature considerations, and I finally come out with my answer, which is 1850 lumens. This is the kind of exercise that we can help you go through, or the kind of exercise that you can walk through yourself to determine what is the required lumens of my LED to get the same output from my system that I did with my old F28T8. This whole study is based on a plastic LED which has a 160-degree beam angle. If you go with a glass tube, you are going to have some fixture efficiency impact. So instead of 90% efficient, you might take off 3 or 4 or 5% reduction in those lumens because of the LED actually using the reflector and bouncing light off of it and therefore losing some of its light. Look at this slide, study it, and see how you can use it to determine what you would actually put in as a direct replacement for an old fluorescent tube. This is all a type A situation, and that fluorescent tube would be taken out and the LED would be put directly on it, assuming compatibility. Let's move on to the way that you can identify GE, A, B, and C tubes. So I put this slide together because I know it's a constant question. If I pick up a GE tube, how do I know what I have in my hand? This is the decoder ring. This is what you've been looking for. All of our GE Type A tubes will have a lamp description stamped on it with ink. And that lamp description will say LED, it will say 15, 18, it will be the wattage. After that number, there'll be a letter. If that letter is an E as in echo, it is a type A LED tube, which goes on an E or an electronic ballast. If the letter after the wattage is a B, as in boy, then it means that it is a type B lamp. Now, if you pick up a tube and you see LED 15 and you don't see a letter after it, then that means it is a type C. It'll say like LED T8, T8 meaning that's the size of the tube, tubular 8/8 of an inch. Now, in the case of our type C lumen choice, we are putting in LC instead of a wattage. So we'll say LED T8 stroke LC, meaning lumen choice. So this is the page that you need so that when you pick up an LED tube made by the General Electric Company, you will know immediately whether it's an A, B, a C regular, or a C lumen choice. That's it for the seminar. Hopefully you found it useful. I put these questions together just to remind you of the key points of the seminar. So let's go through these. First question, Underwriters Laboratory has identified 3 categories of LED tubes. What are they? Let me think. What are 2 strengths and 2 weaknesses of the 3 different UL type tubes? I think you can answer that. Which of the tube types is the least expensive to install, and also which is the most expensive to install? Number 4, are rebates available for LED tubes? What organization was created and who actually controls and populates the qualified products list? What is GE's web address for LED lamps and fixtures? Number 6, what are some of LED tube variations that are manufactured by GE? Well, we just went through those. And then finally, of the UL LED tubes made by GE, how do you identify each type by looking at its lamp description? So I'm going to give you a few minutes to think about this. You can put the video on pause, and then when you come off pause, we'll go on to the next slide. Why don't you pause it now? Welcome back. Underwriters Laboratory has identified 3 types, A, B, C. What are the strengths? You can see them. I'm not going to go through this and take up your time. You can certainly read these, but this is just a high-level review of the video. I want to thank you for your time and your interest. I hope that you find these videos useful. This is the 3rd of a series of videos that we've put together. We've done LED basics, we've done LED reliability, now we've done the ABCs of LEDs. For now, all the best to you and yours. Thank you so much for your time. This is David Korow signing off from Current powered by GE at the Institute at Nela Park.